things aren't always nice, flat, shiny, round, well-polished samples. You get little pieces like this, little rods, turnings, and you know, with X-ray devices, which analytically do a great job on these things, the problem with X-ray devices is you can't really hold things up in front of the window, so you have to get a test stand and a lid. It's got to be interlocked. It's just a lot of stuff to carry around and extra hardware that you really shouldn't need. So here's the nice thing about LIBS. With LIBS, with this particular LIBS, it's an eye-safe laser, so it does no harm to your eye, to your skin. You can use it freely without any regulations or restrictions. So there you go. You can see it in the image. You see my finger. You can see the rod. You can kind of locate it right in the sights of the laser right there. You hit the trigger. You see the laser rastering around. There you go. 304 stainless. That's what it is. Another piece. This is a little smaller wire. It's about a little over a millimeter or so in diameter. I believe this is a nickel alloy. Same thing. We've actually made a little groove here, so a lot of these smaller pieces you can kind of get a good feel with your finger. That's it. Hastile B3. There you go. So see, I have my fingers there. No harm, nothing. It's been approved as a Class 1M safety device. Another good example, how many times you encounter a little, not a turning, but a little piece of small parts. People have to test hundreds or thousands of small parts a day for PMI testing. So same thing, you kind of put that in there, get the feel for it. Now you move there you go, it's this common brass alloy, CDA 673. So that's how easy and quick and safe, most importantly safe, it is to test a small part. Now we can go on to this turning. This is probably this is the thing that can really cause you trouble with an X-ray device, because if you have a barrel of these, often you'll have to, because you don't want to hold them in your hand, you'll be forcing the unit onto the turning, which can lead to a broken silicon drift detector and a very large service bill. Again, the nice thing about LIBS is, first of all, here's a turning. I can stick this thing in there, I can wiggle it all around, no problem, nothing to break. Thing's still going to work because there's a thick quartz shield on there that keeps the optics away from any foreign object, and it can be thick because we're dealing with optical light. It just has to be transparent. So now you test a turning, just shove it up there and like that. And there's your sparking. Try to get it on the spark. And there you go, 5 chrome. Which is common petrochemical alloy. Another nice feature, and then some of those tests we were doing, just to show you, got another advantage of LIBS. This is a beryllium copper. You see you got about 1% beryllium. You've picked that up very quickly with the LIBS unit. So a lot of these elements you cannot analyze with other technologies you can with this. This is I think it's a aluminum alloy, obviously. Nice thing we like to show about this is it's got a little bit of lithium in there. See, there's about 0.3% lithium. Again, you can't really do that with XRF or really any other handheld technology at all.